The technique involves removing vegetation at periodic interval and drying the sample to a constant weight to obtain an accurate estimate. The production of plant biomass must be sampled throughout the growing season and the contribution of each species must be determined. Different species of plant reach their peak production at different time during the growing season. The difference in standing crop biomass between harvest period expressed as germ per square meter per unit time provide an estimate of net primary productivity. Caloric value of the material can be determined through use of calorimeter and biomass can be converted to calories. Net primary productivity is the expressed as kilocalories per square meter per year. Harvest method provide information about above ground productivity usually become low ground productivity require the sample of root biomass which is difficult at best. Although the root of some annual and crop plant may be removed from the soil, the task became more difficult with grass and herbaceous species and even more so with forest trees. Oxygen measurement method, since there is a definite equivalence between oxygen and food produce, oxygen production can be basis for determining productivity. Oxygen measurement has been used as a measure of productivity primarily for the aquatic ecosystem. A variety of techniques are employed as since there is a definite equivalence between oxygen and food produce, oxygen production can be basis for determining productivity. Oxygen measurement has been used as a measure of productivity primarily for the aquatic ecosystem. A variety of techniques are employed as listed as follow. এটা হলো অক্সিজেন মেজারমেন্ট মেথডে। এ হচ্ছে লাইট অ্যান্ড ডার্ক বোটল মেথড। দিস মেথড pioneered by Gardner and Gran in 1927 is widely used in both marine and freshwater environment to measure primary productivity in an aquatic ecosystem. It is based upon the assumption that the amount of oxygen produced is proportional to gross production because one molecule of oxygen is produced for each atom of carbon. Fixed sample of water from different depth are placed in Perritt bottle. One of the Perritt bottle is covered with black tape or aluminum foil to exclude light or other is kept clear to admit light and allow photosynthesis. Dissolved oxygen is measured trimetrically by the Winkler method or electronically by one of the several type of oxygen electrode. The bottle are suspended to the same depth from where sample were collected with the help of string. After 24 hours, the bottle are removed. Their oxygen concentration is determined and compared with the concentration at the beginning. The decline of oxygen in the dark bottle indicate the amount of respiration by producer and consumer, where the oxygen change in the light bottle reflect the net result of oxygen consumed by respiration and oxygen produced. Adding respiration and production together by subtracting final oxygen concentration in the dark bottle from that in the light bottle give estimate of gross productivity for 24 hours. In other words, the combination of oxygen measurement in the light and dark bottle provide a measure gross primary productivity. The light bottle measure net community production of whether part of the community is in the bottle. The greatest limitation of the oxygen method is low sensitivity, which is dependent on the resolution of the usual method of measuring dissolved oxygen. The method is therefore only useful for nutrient-rich lake with high primary production. Diurnal curve method. The light dark bottle method for measuring gross primary production of the community, defined as the sum of the net plant production and community respiration during the daytime, is seldom applicable in flowing water because much of the community is benthic and heterogeneous rather than planktonic. In such case, productivity of flowing water systems such as stream or estuaries and especially polluted water is measured by an alternative method, the diurnal curve method. The method consists of measuring the amount of oxygen dissolved in water at interval of 2 to 3 hours throughout the 24-hour period, day and night. The rise and fall of oxygen during the day and night is the plotted as diurnal curve. The production of oxygen during the day and its use during the night can then be estimated by determining the area under the diurnal curve. The diurnal curve method measured gross primary productivity since oxygen use at night is added to the produce during the day, thus automatically including the respiration of the whole community. If oxygen diffuse out of the body of the water or into it from the atmosphere at the appreciable rate, a source of error is introduced. However, reasonable correction can be made since diffusion is dependent on well defined physical laws. Hypolimnetic method. In specialized situations such as deep temperate lake, productivity has been measured by a short reverse procedure, that is by measuring the rate of oxygen disappearance in the deep sea hypolimnion during the production summer season. During the summer season, a temperature lake is stratified into upper light level, the limnion, and the lower deep level, the hypolimnion. In such stratified lake, deep water are isolated from the atmosphere for several months. During the summer, they produce no oxygen and are not in circulation with the upper water during major part of the production season, and therefore oxygen substantially consumed by biological and chemical process at this time cannot be replaced before the autumnal mixing period. Hypolimnetic oxygen depletion hence has been considered an indicator of lake productivity since the early 20th century. Thus, the greater the production in the upper, lighter water epilimnion, the more dead cell bodies and other organic matter fall to the bottom, where they decay under the action of bacteria and fungi with the use of oxygen. The rate of oxygen depletion is therefore proportional to productivity. Since decay of plant and animal uses up the oxygen, the hypolimnion method measures the net productivity of the whole community, that is both primary and secondary production of the epilimnion. Carbon dioxide method. The incorporation of carbon dioxide in photosynthesis or the loss in respiration under natural condition can be determined by using infrared gas analyzer. With the help of analyzer, it is possible to measure the amount of carbon dioxide entering or leaving an airtight chamber of known area or volume. In this method, it is assumed that any carbon dioxide taken from the incoming air has been incorporated in organic matter during the period of observation, thereby indicating both the amount and rate of photosynthesis. As there had been respiratory activity during the period of observation, the use of infrared gas analyzer alone cannot be foolproof. So, comparable study is established using a light-tight container where no photosynthesis but respiration alone will take place. The amount of carbon dioxide released from the chamber in a given period will be index of the amount and the rate of respiration activity. The value when added to the obtained in the light exposed chamber will give the total or gross production of the system. The use of infrared gas analyzer is not feasible in an aquatic ecosystem.